When you open MATLAB, it opens a big window for you with different sub-windows. You see in the middle here is something called the command window. This is where we're going to type the MATLAB commands that we want it to execute. Over on the right is the workspace. As we start to type things in, you'll see that it fills in. It's basically keeping track of what variables we've assigned. Over on the left is the current folder. This is useful when you're saving and opening files. And on the top are different icons, for example, for saving and running files and things like that. But let's jump into the command window. First command we'll do is s equals 2. The way MATLAB interprets this is it assigns a new variable called s to have the value 2. If we forget what we assigned a variable to, we can always just type the name of the variable and return, and it outputs that to the command window. Now let's try the following command. Let's just say t return. Notice MATLAB doesn't like that. We haven't assigned the variable t to be anything, so it gives us an error. But we could assign t to be something, and for example, it could be a variable, t equals s. So it takes whatever the value of s was, creates a new variable called t with that value. Now let's assign some vectors. If I say a equals square bracket 1 space 2, what that does is creates a row vector with two elements, 1 and 2. The square brackets are basically just telling us where this will begin and end. We can also use commas to separate the elements. So for example, if I take A2 equals 1, 2, 3, it's going to create a 3-element vector given here. These were row vectors. We could also do a column vector. So for example, B equals square bracket 4 semicolon 3. That gives us this column vector. The semicolon is basically just telling us to move to the next row. And we'll see that in the next example if I want to do a matrix. So let's say we want a 4 by 3 matrix called C. We'll use the command C equals square bracket 106 semicolon, which tells it move to the next row, then 134 semicolon, and so on. So the semicolons, remember, just tell it to move to the next row. So when we press return, we see this as our 4 by 3 matrix. If we forget how big a matrix is, or we want to be able to use for example, the number of rows in a loop or something, there's a built-in MATLAB command called size. We use size parenthesis c, gives us this. The first number is the number of rows, which is 4. The second number gives the number of columns, which is 3. Next, let's see how we can access a specific element of a matrix. So if I say C parenthesis 3 comma 2, the first argument 3 is what row I'm interested in. The second element 2 is the column. So if I press return, it gives me the number 6. That would be the 3, 2 element of the matrix. We can also reassign a specific element of a matrix without having to retype the whole matrix. If I say, for example, C1 comma 3 equals 9, it's going to take the 1, 3 element, that is the first row, third column, which was a 6 before, and now it assigns it to the value 9. Next, sometimes it's useful to pick out, say, an entire column of a matrix. You can use that. You can do that by using the colon. So let's say C parenthesis colon comma 3. The way MATLAB interprets this, the first argument is what row we are. Colon basically means all rows. And then the second number, 3, is the column number. So if we press return, it's going to pick out the third column. All rows, third column. We can do the same thing if we want to pick out a row or something similar where we say C parenthesis 1 comma colon. So MATLAB interprets this as first row, all columns. So it picks out that first row. You can also use the colon to conveniently assign certain types of vectors. So let's say we type in h equals 1 colon 8. The way MATLAB interprets this, the first number 1 is where I want the vector to start. The last number 8 is where I want it to end. And by default, it increments by 1. So this creates a row vector 1, 2, 3, 4, 5, 6, 7, 8. If I don't want to increment by 1, I can tell it what the interval should be. So for example, if I do t equals 0 colon 0.5 colon 3, MATLAB will start at 0, increment by 0.5, and end at 3. So we get this vector here. Now, this is useful if we know what we want the increment to be, but sometimes we just want to specify where we want a vector to start, where we want it to end, and how many elements total there should be. We can do that with a built-in command called linspace. So if I say t2 equals linspace 0, 3, 7, it creates a vector that starts at 0, ends at 3, with 7 elements, and it chooses what the appropriate increment should be. And you see that it gives the same answer as what we got for t up above.